Good morning, students. How are you doing? So, friends, in the last lecture, we started an important topic on assignment problem, right? So, if you remember, the problem was like that. Tata Motors decided to assign 4 jobs of its ambitious project on Jaguar Land Rover to the 4 renowned engineers. So, the name of the 4 renowned engineers were Viraj, Rana, Dev, and Ritu. Following table indicates the cost of assigning jobs, that is 4 jobs, to 4 renowned engineers in lakhs of rupees. So these were the 4 jobs, job 1, job 2, job 3, job 4. And these 4 jobs were required to assign to, means each job is required to assign to one engineer, right? For example, job 1 can be assigned to either Viraj, Rana, Dev, or Ritu. Similarly, job 2 can also be assigned to Viraj, Rana, Dev, or Ritu, means any one of the engineers. So, like that, if first job is assigned to Viraj, then second job, we are left with 3 possibilities, right? So, if there are n jobs, then by n factorial ways, you can do this distribution or assignment. So Tata Motors wants to assign each job to a renowned engineer such that total cost incurred is minimized, right? So they wanted to minimize the cost by assigning jobs to uh, engineers in such a way that your cost can be minimized. And the task has been given to senior manager, that is Ms. Navneet Kaur, which is an expert and who is an expert and has a wide experience in minimizing total costs. So then we drawn this network flow model that there are 4 jobs, J1, J2, J3, J4, right? So each job can be assigned to uh, any one of the 4 engineers, right? So, and 2, 4, 6, 10, these were the cost of assignment. If job 1 is assigned to Viraj, then it will cost 2 lakh rupees. If job 1 is assigned to Rana, then it will cost 4 lakh rupees, right? So, and then we had two important constraints. So, objective was to minimize the summed over I, summed over j, Cij into Xij, and that was subjected to two constraints. One was that summed over I, Xij is equal to 1 for every j, means job, uh, yeah, so job 1 can be assigned to Viraj, job 2 can also be assigned to Viraj, job 3 can also be assigned to first engineer. Similarly, job 4 can be assigned to first engineer. Similarly, these 4 jobs can be assigned to the second engineer, also to the third. It can be assigned to any one of these. Similarly, for the other constraint, summed over j, xij is equal to 1 for every I, means the first job can be assigned to either Viraj or Rana or means any either to the first engineer or second or third or fourth. So today let's see how we can solve this problem using solver. So I have drawn here the table which was shown, right? So 4 jobs and 4 engineers. Okay, so first you need to, you can write down decision variables. Yeah, so we have decision variables. So the decision variables are your xij's, right? So it will be your x11, x12, x13, x14. Similarly, x21, x22, x32. No, sorry, it will be x21, x22, x23, x24, then x31, x32, x33, x34, and x41, x42, x43, x44. So these are our decision variables, right? Okay. Then we can write the CIJs, all the CIJs available to us. So C11, C12, C13, C14, right? C21, C22, C23, C24, C31, C32, C33, C34, and C41, C42, C43, C44, right? So these are the costs of assignment. So here we have seen that decision variables are binary in nature, right? Either you will assign or you will not assign. So xij will be 0 if the ith job is not assigned to jth person, and it will be 1 if the ith job is assigned to jth person. Okay, anyhow, so xij's randomly right now we can assign randomly. I'm just assigning randomly, right? So suppose I am assigning first job to fourth person and second job to third person and third job to second person. Right now I'm randomly assigning the job. I don't know which job is which one assignment is optimal, but right now just randomly I am assigning, right? So I have assigned first job to person number engineer number 4, second job to engineer number 3, third job to engineer number 2, and fourth job to engineer number 1. And what are the cost components? Cost components are given over here. So I am directly copying it, Control C, and putting in this table, right? So these are the CIJs, right? Now I am having XIJs and CIJs. So what is the objective function? So what is the objective? Objective is to minimize, that is Z is equal to summed over I, summed over J, your Xij multiplied by Cij, right? This is the objective function which we are having. So this is the objective, right? So objective would be equal to now Xij into Cij. So X11 into C11 plus X12 into C12 plus X13 multiplied by C13 plus x14 multiplied by c14 plus x21 multiplied by c21. Similarly, I'm now doing all these things plus x23 multiplied by c23 plus x24 multiplied by c24 at x31 multiplied by c31 plus x32 multiplied by c32 plus x33 multiplied by c33 plus x34 multiplied by c34 plus x41 multiplied by c41 plus x42 multiplied by c42 plus x43 multiplied by c43 plus x44 multiplied by c44. So these are our objective function, that is minimization. Objective function z is equal to summed over I summed over j xij into cij and enter. Right. So right now the objective function value is randomly we have calculated, that is 38 lakh. But you know the answer. Yesterday we solved it using assignment algorithm, right? Hungarian algorithm. But today we are solving it with solver. So now we have defined decision variables, objective function, and now it's time to define the constraints. So constraints, you know. So we had two constraints, major constraint. One is summed over I, xij is equal to 1 for every j, right? So it will give us four numbers, that is x11 plus x21 plus x31 plus x41 is equal to 1. So yeah, means out of all these four jobs can go to Viraj. That is x11 plus x21 plus x31 plus x41. That is equal to 1. It can go to Viraj. Similarly, these four jobs can go to Rana. That is the second one. Then these four jobs can go to Dev, right? So this is our xij summed over I is equal to 1 for every j. J is for either once it is Viraj, once it is Rana, or once it is Dev, like this. Other constraint is summed over j. Xij is equal to 1 for every I. Means these job number 1 can go to any one of these first, right? Then this job 2 can also go to any one of these four engineers. So this is the second constraint. So let's define them. Yeah. So first is x11 plus is equal to sum x11 plus x21, x11 plus x21 plus x31 plus x41, right? That is equal to that is equal to 1. Second is x21 plus x22 plus x32 plus x42. Just a minute, is equal to sum, yeah, sum is equal to 1. Then third one is equal to sum x13 plus x23 plus x33 plus x43 is equal to 1. Fourth one is x14 plus x24 plus x34 plus x44 is equal to 1. right? This is the fourth one, and fifth one is x equal to sum x11 plus x12 plus x13 plus x14 is equal to 1. Then x21 sum x21 plus x22 plus x23 plus x24 is equal to 1. Then let me write equal to 1. Then it's equal to sum x31 x plus x32 plus x33 plus x34 is equal to 1. And the last one is equal to sum x41 plus x42 plus x43 plus x44 is equal to 1, right? So now we have defined all the constraints, right? Now our mathematical formulation is completed, right? We have objective function with us, we have constraints with us, right? And all xij's are binary, having binary values, 0 or 1, right? Okay, now let's solve it using solver. So we'll go to data. We have solver over here. Click go. Now we need to set the objective. So objective is this particular cell. So I have selected this, and by changing variables. So variables are from just a minute first. So by changing cells, we need to find out the variables, value of decision variables. So I am selecting these, right? Now subject to the constraints. So let's add constraints. So we have these 8 constraints over here. 1, 2, 3, 4, 5, 6, 7, 8. And all constraints are equal to type. So I'm putting equal to sign, and the right hand side is I have selected all the cells of right hand side. So now click OK. So we have set objective function, which we need to find out. And the problem is of minimization. So we have clicked minimize. And by changing decision variables that we have selected, and then we defined all the constraints. Now this problem we are going to solve as a linear programming problem, right? Even if we'll solve this problem as a linear programming problem, it will give the algorithm is such a way that it will give solution in binary variables, right? So let's now click on the solve. Yeah. So okay. Yeah. So now you can see that, yeah, objective function value comes out to be 15 lakh rupees. And yesterday we got this much amount of allocation, right? So yeah, so how it is going to be allocated? Yesterday we also, let me see the sheets, sheets on which yesterday I did. Yeah, so here you can also see that job 1 went to Viraj, job 2 went to Ritu. Here also you can see job 3rd went to they, yeah, and job 4th went to Rana. So here you can see that we have got the same answer by using the solver method, right? So this is the way by which you can use solver for solving. This is a simple example, but if you are having more a big problem, assignment problem, then solver will help you in solving in a rapid manner, right? So if you are having any doubt, you can contact me. So thank you very much, friends.